Good morning, everyone. Happy Friday at 6 a.m. I'm excited to see you as every Friday for the last 4 weeks. Let me know where you are tuning in from. Leave me a comment with a hi and the place you're tuning in from. Hi from Pennsylvania on my end, from Fairfield, Pennsylvania. So we are still doing this at 6 a.m. this week, but when I'm going to Poland in August, I'm going to be feeling like I'm cheating because it's going to be probably, well, 6 hour difference. Not probably, it's going to be at 12. So let me present my screen. Okay. Let me know where you're tuning in from. Good morning, Robert. You're always there. I appreciate you so much. This is like, and Robert is in the US time zone, so he's actually, oh, my camera stopped working. Okay, I'm back. He's actually here every day. And we have, noon in Europe. We have some people joining from Europe. Most of our people are on LinkedIn, I'm seeing. If you're watching this on a different platform, on wrong camera, on a different platform, on YouTube or on Facebook, let me know which platform you are watching on. I'm gonna see if I can change the camera to the right one. If not, that's okay. Okay, we have the correct one. Good. Oh, we have somebody from Switzerland. And it's a Polish girl from Switzerland. Hello. Okay, I don't see the LinkedIn names today. That's okay. Anyway, whenever you join, okay, we have somebody from India. Welcome. Whenever you join, let me know that you're here. Let me know where you are tuning in from. And let's start talking about those papers. So I think I did a little bit of a mistake because normally I just, normally I just highlight those papers with a highlighter and then I draw on them, and I decided to like pre-read them yesterday and already draw. So we're gonna have even more drawing. I'm gonna take yellow for today for like marking everything. Good morning. Okay. Oh, and people are watching on LinkedIn. I don't see anybody watching on YouTube. If you're on YouTube, let me know. In the meantime, let's go to our first paper. I have a lot today. I don't know if we're going to cover all of them, but there was one called Latent Diffusion Models with Image-Derived Annotations for Enhanced AI-Assisted Cancer Diagnosis in Histopathology. What does that mean? Latent diffusion models. So have you heard of Stable Diffusion or Midjourney, or those like companies or models that are making like fake images? So it's about a model like this, and this group is from Berlin, Germany. So big hi to Berlin, Germany. This is where I did my residency. By the way, let me know audio and video okay. Give me an okay in the chat if everything is okay. So this group from Bayer, it's a pharmaceutical company, or also agricultural, they did this, and what they did is, so let's start with why. You always should start with your why. Why are you doing what you're doing? So developing supervised AI models requires large-scale annotated datasets. I can confirm that. I have been part of different initiatives for developing models, and you need to annotate a lot. So how can we generate synthetic data? And the concept of synthetic is basically like fake data, but that could be real. So something that it's easy to imagine synthetic data. I mean, images is also easy to imagine, but tabular data, for example, when you have different parameters, let's say, I don't know, pressure, blood pressure, whatever parameters that you can do as tabular data, you can basically like make a table of fake patients that those data are totally plausible. So you're not using real patient data. So here they wanted synthetic data, synthetic images. So those diffusion models can generate high quality, diverse synthetic data. And this is very promising, right? And implementation relies on detailed textual descriptions, which are not generally available in this domain. So just too much. See, next time I'm not going to be coloring it for you because it's just confusing. But I have a little question mark here. Why do I have a question mark? Because I'm like, it's not, well, okay, data in pathology is very precious and we have a lot less than like Google or in general medical images. You have a lot less medical images than like natural images, and natural images are the normal pictures, dogs, cats, people, anything. But when we have pathology images or radiology images, sometimes you have a very detailed report going with this. But of course, it's not like patch by patch, it's rather full description of an image, or not really of an image, of a case. So several images, and you describe different features there. So I agree. Yeah, let's say I agree. I do not disagree anymore. So what happened there is they used this PCAM data set. There is a data set, and they had tissue patches only loosely annotated as healthy as cancers. And several of the models that were famous, like that was the model that the page prostate algorithm was based on, that would divide image into patches and say cancer, non-cancer, cancer, non-cancer. Still, per patch, it's weak label, but when you take all the patches in the images, it's actually a lot stronger than just one label for an image, cancer, non-cancer, especially if it's cancer, because you don't know where this cancer is. In non-cancer, you can know that. So that's what they did, and they generated synthetic data. And what they shown that it improved this fasciate inception distance, FID, by 88.6. So it was good. And they also showed that pathologists it was challenging for them to detect synthetic images from real images. So synthetic data can be effective to train models. That is the first paper that you can make fake images to train models. The detection was like 55 sensitivity specificity, so they still could detect it, but they had trouble. So interesting. Why is it interesting? Because as I said, medical imaging, we don't have so many images. It's if we can create synthetic to train models, so you're like not using these synthetic data for any decisions or anything, just to train the model. Okay, I decided to skip number 2 because this is in sensors and it's very technical about. Okay, let me just tell you that they this group from Wuhan decided to have a lightweight attention network, so a model that is easy to deploy for skin lesions. These are skin lesions that are gross, so no histopathology here, and they needed this lightweight model because it has to be deployable in devices in the clinic. So you have to like plug it in into a medical device, and it needs to be easily deployable. So they made this lightweight. But let's check something. where we are actually using our friends' large language models. And I see more people joining. Welcome, everyone. Whenever you join, let me know where you're tuning in from. In this third paper, deep learning-based dynamic risk prediction of venous thromboembolism for patients with ovarian cancer in real-world setting from electronic health records. So some of those records are text. Interesting. And I know Erica last week wanted to have a specific ChatGPT session. We have several GPT papers here in this particular session. So this group from Korea, I love how their abstract is structured. Let me make it full screen for you. So like, okay, what's the purpose? What are the methods, results, and conclusion? So that's basically beautiful for us especially. So what happens here? Patients with epithelial ovarian cancer have an elevated risk of venous thromboembolism. And there are different models that assess this risk, the statistical or machine learning algorithms, but few have used deep learning in realistic clinical settings. So they aimed to develop a predictive deep learning model and exploiting the information from electronic health records, including dynamic clinical features and the presence of competing risks. So interesting. And what do they do? What did they do? They had a lot of patients, 1,268 patients diagnosed with epithelial ovarian cancer, January 2007 to 2017. And with this model that they developed that leveraged deep learning, they had prediction accuracy independently validated on 423 patients. And the results were this new deep learning based survival networks achieved a superior area under the receiver operating characteristic curve of 95 and 98. See, I cannot pre-color these things for you because you don't see what they actually, you don't see the results. That's next time I'm going to be better. So basically, nice OROC, and the conclusion is that adapting dynamic patient clinical features and accounting for competing risks demonstrates higher accuracy when predicting this thrombosis. So they use deep learning, electronic health records, and they had better outcomes. I mean, better results. Here, I wanted to highlight the next publication because it's in PLOS ONE, so nice journal, and it's from Pakistan. And it talks about deep learning empowered breast cancer diagnosis, advancements in detection and classification. So it's kind of a review. And what they say here is that we now have computer-aided diagnostic systems, CAD. Sorry. Computer-aided diagnostic systems. So what is a CAD? It's like a type of a medical device or option for a medical device that assists the physician, assists the doctor. And I'm gonna be recording a podcast episode with a radiologist, with Dr. Nina Kotler. So I don't know when it's gonna be out, but in radiology, they have different options to deploy AI-based medical devices, and I'm going to learn from her what these categories are. One of them is CAD, computer-aided diagnostic, where you still have the physician, the doctor in the loop, looking at everything. And here, so this is on radiology images actually, because they say that mammograms sensitivity and accuracy of the mammograms can vary. So how about we use those CADs? And they that's what they're reviewing, that they had CADs based, deep learning based, computer aided diagnostics for radiology. So again, the pathology is breast cancer, the modality or the specialty diagnosing it here is radiology, and they were able to categorize breast lesions, segment them, classify them, and they validated this through a Pakistani database of mammographs, and they had very nice accuracy of 98.5% when segmenting and 99.16 for classification. So they say you should use this because it's better. And we have ChatGPT for pathology research. So we have a couple of papers about ChatGPT. And it's funny because you're going to see that some, like, ChatGPT is, or you know, the large language models in medical journals. Now it's like, okay, you're gonna find a paper that is basically like telling you what it can be used in medicine, why it can be good or bad, like kind of. Because like something that you would find on the internet without any problem, and anybody who already used those language models knows about it, but then you have people write it for medical journals to have this be available in medical literature. And this one is from Lancet. So Lancet is a good journal as well. How do you like my cap? This is a Polish pattern pottery from Bolesławiec. That's what my coffee is in today. So ChatGPT, what did they say? And this group from Cornell Medicine and Dana-Farber Cancer Institute. This is some kind of viewpoint paper, and they explored the integration and challenges of LLMs, large language models, in pathology. So the main problem that people see is that this is not domain specific, and the fear is, okay, if it's not domain specific but gives you like plausible information that you as non-expert, or even like, let's say, expert with expertise in a different domain that you're asking the question about, if it's going to give you an answer that's plausible, how do you know that it's correct? Well, you may not know, because and the problem is because it's not domain specific, but it can be. So their initiative in digital pathology emphasizes the potential of domain-specific AI tools, where you can curate literature databases and basically give this, coupled with user interactive web application, facilitates precise referenced information retrieval. And the keyword here is the retrieval. So there is a technology or a way of using large language models where you restrict them to a certain database of information, and you can teach it, okay, just take information from here, always reference where you have taken it from, like highlight the fragment, highlight the PDF or whatever, like tell me where you took it from. So you can use the generating capability of this large language model, so it can like talk to you, but it brings you information just from a data set that you you trust, you want to use. And this is called the retrieval augmented generation. So this is one way of having something domain specific, like you put your domain specific, your pathology information there, and you just have the language model like crawl it, or work with this particular data, right? So like you have an assistant for working with this particular data. And why do they say this is important? Well, first of all, of course, it's important to increase the accuracy of what we're doing there with ChatGPT, especially for any medical application. But also, they say this streamlines access to scientific research and democratizes access to computational pathology techniques for scientists with little coding experience. How does it do it? Well, you can basically tell, so ChatGPT or the large language models, and by the way, like how famous of a product is the ChatGPT that instead of us calling this technology large language models, everybody says ChatGPT. It's like Kleenex for tissues, like fantastic branding. Anyway, so this ChatGPT, see, I lost my train of thought. But okay. So it's not good with numbers. Like it's a language model, so it's good with language, but not with calculation. But let me tell you what's out there. Special languages that can code calculations, the coding languages, the computer science languages. Programming, it's called programming languages, so like Python, C++, whatever, right? So you can tell ChatGPT or large language model with words that you wanted to code something that calculates something else. And I have here this word highlighted, agents. Agents. So basically, now I recently saw a presentation by AWS. Maybe I already told you last week. Amazon, yeah, Amazon Workspaces, and they were talking about these agents. So an agent is like a large language model prompt that can code something that later deploys. So you kind of like have a virtual programmer. You tell this programmer to code for different applications, and those virtual programmers, those agents, can work together, and you can like have a bunch of them strung together that then write code to deploy calculations and deploy different things like that. And basically that gives people access, or people who cannot code. So I could do it if I wanted to. I don't code, but I have like an understanding what I would like a program to do. So yeah, that's what they say in Lancet is the new thing with ChatGPT. So this is a little bit beyond the, okay, what ChatGPT does in medicine and why it can be useful. Anybody on YouTube? Anybody watching us on YouTube today? Let me know in the comments. And also, if you have questions to anything, because after 30 minutes, I'm going to stop discussing papers, and whoever wants to stay and have questions answered, you can do that. So please post your questions in the chat. And so something I wanted to mention, this EMPAIA. This is an initiative in Europe, and I actually know Norman from Online Interactions, and this group is in Germany, and in the Charité. It's a prominent hospital in Germany, and they have this EMPAIA initiative. What do they do in this initiative? So it's an open and vendor neutral initiative. And they integrate various stakeholders in the pathology AI ecosystem. I like that they say ecosystem, because it is an ecosystem, right? So they also mention different stakeholders, pathologists, computer scientists, and industry. So you always will, in a regulated environment, you have the regulatory people and validation people, and basically it's an ecosystem. It's a multidisciplinary group, and they have this in Europe. So let's check it out. EMPAIA, Common Open Source Interfaces. So it's an open source platform that integrates different systems from different vendors. So definitely something to look into. Last week we were doing liver fibrosis. So and okay, so I want to contrast the previous ChatGPT paper with this one. This one is by a group from New Delhi, India, in this journal, Rev Esp Patol, Revista Española Patológica, maybe a Spanish journal of pathology. Let me check. I'm gonna check later. But anyway, so in here, you can, it's more like the early advertising of the use of ChatGPT in medicine, because they say, oh, it's much hyped AI model ChatGPT developed by OpenAI. And here they mentioned certain roadblocks like integration with image analysis. And then the challenges are biases from the training data, and bias and transparency, and potential adverse outcomes arising from inaccurate content generation. So these are the fears that anybody like in life has, that it's going to give you fake information and you're going to take it and you're going to talk about it as if it was real, right? But this paper is kind of like the earlier way of talking about it. The Lancet paper already says, hey, there is a way to take care of it. So, and it's also a higher impact factor. And that is it for the papers today. Let me know if you have any questions, any wishes, or anything like that for future sessions. I have a few other things that I want to tell you, but it's in my other notebook. And so I was so excited to be here all week. And from the beginning of the week, I was like making notes, what I want to tell you about. So last week, I was talking about me wanting to make a course out of the YouTube videos. So actually, I realized that the platform I currently host my membership on can support that. So that's going to be. Oh, my mug. Somebody got from Poland got a bit homesick, sick about my mug. So, oh, amazing. So Wrocław is where I studied veterinary medicine. This is where my sister lives, and I might have gotten this cup in Wrocław. They have a specific shop for this. So anyway, so I'm going to be hosting this YouTube course on the platform that I use. It has an app, so you can access it through the phone, and whenever it's ready, I'm going to let you know. But for the membership, whoever is a current member, or if you want to join the membership, you can do that too. And we're going to be starting monthly Q&A calls. So ask me anything digital pathology. Every month, the members will be able to be part of that. And we're just gonna use these calls and the journal clubs in whichever form they evolved as our mental gym, a mental digital pathology gym. So it's so crucial to stay consistent. So I'm gonna turn 40 this year, and last decade, when I turned 30, I was like, I want to learn to play accordion. And I bought myself an accordion. And then I like, this accordion is still collecting dust. I never learned to play accordion. And because it was like too difficult to get classes anyway. And I wanted like a full-blown class because I used to go to musical school and I know like how much effort you have to put in it. So, and it was like so much that I didn't do anything, and life came in, and now I decided to pivot and do little steps. So I found, first of all, I'm going to start with ukulele. So maybe one day I'm going to come and play a ukulele song for you. And I found online classes that I'm going to have once a week, and half an hour, whatever. And if this is the only thing I do for this ukulele, and if you're a musician, or everybody knows that they practice a lot, this is like zero, nothing, half an hour a week. But then it's also so much more than actually not doing nothing. So it's not nothing. It's half an hour every week, and then if I get to practice, fantastic. But then it will accumulate in 1 year, 2 year, 3 years into me being able to play ukulele. So this is how I'm seeing our sessions here as well, and this is how I'm seeing like. Because this is adult education, so it's so much different. Oh, and I see people on Facebook, I think. Is anybody on Facebook? Anyway, adult education is so much different than kids education, or like school education or structured education, because you can like sit in a class, you have dedicated time to do homework and all that stuff. And adult education, no, everybody has life, everybody has commitments, stuff that they have to do for work. When you take part in something like this today, what you take out when this is finished, that's it. You're not going to go back, watch the recording. Maybe you will. I would love you to watch the recording. But most of the time, no. Most of the time, we're lucky to be able to like take part in this webinar, actually read this book or whatever. And whatever sticks, sticks. So uh, doing this over a cumulative period of time, even if a fraction of this sticks, when we do it consistently, it's like a gym that's gonna get us to a better level in digital pathology. Both me, because these are new papers that we are reviewing, and you as well. Even, you know, if it's just the title that you heard, like until we started these sessions, I was not doing it on my own. You know, I would like read one paper in full and not scan these abstracts. So yeah, and consistency is key, even if little steps. And I hope I'm gonna be able to show you my ukulele. And I also signed up my kid for Spanish, so he's doing Spanish online for half an hour every day. Sorry, twice a week. So I want to be as consistent as he is. He just shows up, does the plays with the teacher, and you know, after a year or two, he's going to be able to speak Spanish. He already speaks some. Mm, yeah, and also I wanted to let you know that I'm not quitting on this. We're gonna keep going. And why am I saying this? So I'm a runner as well, and recently in my running group, there was a discussion: or are we gonna, what's gonna happen with the running group? And my coach was not sure if he's going to continue. And when he said that, I was like, if he's not sure, like, why should I care? So I just want to tell you that we are continuing and I care, and I'm going to be here for you every week, circumstances permitting. Mm, ah, and a cool tool that I discovered. So ChatGPT is, you know, the Kleenex of large language models, but there's another model that I use a lot. It's called, can you see anything? No, it's called Claude. And ChatGPT is already available for the phone, and Claude is as well. Good morning, Alexandra, says Claude to me. So there's an app for the phone for another language model, and I'm actually paying for the paid version, but you can just have an account for free as well. It always lets you have like a couple of queries a day. Um, yes, I don't see any other questions. If you have them, or if you're watching the recording, feel free to leave them in the comments. And I'm gonna see you next week for our 5th DigiPath Digest. Thank you so much for tuning in, and I talk to you in the next session.